Hello, everyone, and welcome back again to the session on Python for data science. So I hope all of you are enjoying the training so far. And we've come a long way in learning Python basics all the way to now having learned how lists work, how operations on lists work, how tuples work, all of that. So we've viewed different data types. We're now doing dictionaries and sets in Python. And just the way in a list you can save, a collection of items together, which allows you to store arrays of information or matrices. Dictionaries are very, very useful when it comes to data that you want to very quickly find out. So if you want to keep ledgers of, names of people and you want to search by a particular name, etc., dictionaries are very, very efficient to search those items. Whereas sets, on the other side, give you uniqueness of items, which means you can have a collection of items that are unique. So if you want to find out at any point in time if a particular item is present in a set or not, it's easier, more operationally efficient to find that out in a set than to actually find it out in a list. So while they all look like collection types, they actually have very, very different purposes. Now, the purposes might not be clear very much right now, but the concepts are very important to understand. So as we move on along our data science journey and we start doing machine learning, models, etc., including real life data preparation, taking data, cleaning it, or transforming it, computing the eigenvalues, eigenvectors, for example, computing an identity matrix. In all of those things, you will actually have a lot of use for these basic concepts. And a lot of this comes into part of exploratory data science, where you're actually taking all of these dictionaries and sets and using it to clean your data, prepare your data, normalize it, denormalize it, structure it in a particular way. So it's something that's really, really used on a daily basis by a data scientist. So dictionary and set is something that you might actually use more often than you use machine learning as a data scientist, right? Even pushing data to simple charts and dashboards, even if you're not doing machine learning, you're not doing any AI, just simply pushing the data to charts and dashboards will actually require you to use a lot of these frameworks. And frameworks like NumPy and Pandas, which we will do next week, rely heavily on dictionaries and sets and lists and tuples. So let's get back to it. And it's a very exciting session. And Suvir is doing a wonderful job in walking us through all of these concepts, making sure every one of you understand. So do not hesitate to ask questions. These are really important concepts that you're learning. Please go ahead, ask as many questions as you like. Our intention is to make sure that you understand these concepts fully inside out. Sometimes the syntax can be complicated to remember. You might not remember the syntax. You might not remember where to put a comma, where to put a colon. This is normal when you're starting with programming. So you can always come back to this video, watch the video later, and you can then revise your syntax. So understand the concept. Don't get bogged down by the syntax. Syntax you can always Google. I myself do not remember the syntax, right? I do programming every single day, but I program in several languages. Half the time I'm doing Java, the other half the time I'm doing Node.js, other frameworks like HTML, etc. It's not possible to remember syntax across all of these languages. And you will now learn R programming, Python programming, all of that. So don't at all be bogged down by syntax. If you don't remember it, that's fine. That's why you Google it and you can find it easily. What's really important is to understand conceptually how it works and what is possible and what is not possible. So let's get back to it. And Suvir, let's get started. And if possible, we can try to finish Python today, but no need to rush. We actually have some time tomorrow if it spills over.
Sure. Thank you, Sanket, for that heads up. Okay, guys, welcome back in the session. I hope you had a good time at your lunch. And since this is the second half, I would like you to be a little uncomfortable because after the lunch break, probably we should not feel a bit sleepy in Python class. So try not to switch on your air condition or maybe on the fans so that you are kind of a bit awake on this session. So we're going to cover what is left from the first session. And as BlobCity said about, we will try to stick on to this topic and try to cover it and complete Python core as far as we can, but we'll try our best to understand and go. And in case if anything is left, we can discuss it in tomorrow's session as well. And please ask as many as questions you can. I'll try to answer the questions. For some of the questions, sorry, because of the fast scrolling, I miss on some of the questions, but if that is reposted, I'll try to answer that as well. So I'm going to share my screen. So please do let me know if you will see the screen. And I have not shared anything. I have not changed anything on the screen. So you should just look the way it was before. Okay. So let's scroll a bit again and say, what are dictionaries? We know dictionaries are typically the data structures in Python. It is a format in which the data is stored. It has its properties and characteristics. Could be like storing a heterogeneous data, could be storing about the format in which we are storing the data, like a key value pair. And that's what we have seen, that dictionaries are just key value pairs. People, those who have worked a bit on Java and have worked on MapReduce programs, I'm just assuming if there's anyone, then this is more or less the same concept. But yes, dictionaries work on key value pairs. We will see what are the other possibilities, what we can explore in the dictionary. Okay, so this is what we had covered, that if you look at the first syntax, and just as it was, I will reiterate that in case if we have difficulty understanding the syntax, it's totally okay. See, there could be three different programmers who could, give the same output, but write the program differently. So everyone can use their own wit and can have this thing done. But yes, a logical understanding is very much required. Do we require exception handling and data processes, wrangling and model deployment? Anil, a very good question. Anil's question is that, do we require exception handling and data processing? See, anything whenever you're trying to bind them together, not in just Python, but anything that you want to bind things together so that it gives one holistic result, you will definitely have to have exception handling codes onto that. So let's say the first thing which generally people start being a data scientist is data scraping. So they start scraping the data from web pages and websites and try to identify what kind of data we are getting. In fact, that's a good way also to start. Ethical scraping is something that you should look on as you're moving forward to be a data scientist. When you scrape the data from web pages, the data which you receive may not be in the same structure which we can see on the web page. It might have some different characters which have come up in the scraping. There's some question marks, some junk characters which have come up. And also when you are scraping, it would be this way that indexes might go on for a toss. So yes, in continuation what to Anil asked, exception handling is very much required when you do programming, either for data science or for a general purpose. So here in this code, in line number 4, we created an empty dictionary, and then we went on with the dictionaries provided for the Tom, values provided for the Tom and Mike, but we did not use a typical way of writing a dictionary. We simply mentioned about standing brackets. So as I said before, that this also applies to data frames or any list for that matter. So if you're putting up this value, it will automatically be created for you in the dictionary. And you have given this instance, right? So you have already given that this is a curly braces. So that means this dict1 itself is a dictionary object. So just like we put the key value pair inside the dictionary, we can fetch a value corresponding to a key. So definitely, if you want to see the Tom's age, this is no different than what we saw in the list. So same things, dictionary 1, standing bracket, and the key for that. I'm sure there would be other questions. They can be passed multiple keys, etc., etc. We're going to look at that. Moving forward, so passing the key to a dictionary will fetch the value for that element. And let's say what happens if the key is not present? Definitely the Python is going to throw a key error. Key error is actually a real error. So if you try to execute you run the code above, which is this one, which actually Harry is not present in our dictionary. Harry is not present in the dictionary as a key, so definitely we're going to have the key error. So this occurs when the specified key cannot be found. So means that developers can have to be very careful. And now this the good question. What continuation to Anil? I think it must be a coincidence. So Anil asked about exception handling. So you can see this part. This key error is again a part of exception handling for people who are unknown to what exceptional handling is. Exceptional handling is when you define, let's say, if a greater than 5. What is the exception that if a is never greater than 5, what you want the program to do? Or when you say you traverse in this list and find a specific value, what if that value is not present? Exception handling is different than else statement. Okay, exceptional handling is handling wherein the cases or the permutations or the combinations which you have not thought about before, or if you feel in anticipation of an issue which might come up when running the codes in the production. So you can write an exception code here that if the key is not to be found, like Harry, don't give a key error, rather pass it. Okay, simply pass it. Bijit, just remember from a previous year, we have not seen anything like how user will give you input like we use scanf. See, scanf is more or less like printf in a particular format. So we can give an input by using an input keyword. Okay, by using an input keyword. So input, and when you run that, it's going to ask you to enter values like name or integers or something like that. Scanf, as far as I remember, is used for printing and reading. Reading a variable value is actually a scanf, if I'm not wrong. So yes, that can be done in Python, very straightforward, Abhijit. Priyadarshini, what is a map? We'll come to that. Map is actually a part of user-defined function, or any function for them. I'll come to that once we reach the functions. Priya, I'm going to talk about that. Okay, so what if this occurs when the specified key cannot be found? So that means when we don't have a key like Harry, so we have to be careful in this part. Sometimes you might not be sure if the dictionary has the key, and this will happen when your dictionary is dynamically created. In such cases, we can use the in keyword to check if the dictionary has that specified key or not. Thanks to Bobby for that. Please refer to what Bobby has written as far as your input is concerned. You can simply use a input keyword, Abhijit, and you can pass in your values, but you also have to define what kind of a structure you're going to read, whether it's going to be a string or integer. So let's see this. Contains Harry. So I have Harry in dictionary 1. So whatever in dictionary, do we have a key called as in Harry? And it says it's false. Okay, so now you see it did not give us a key error, which is actually a good part, because if key error, if any runtime error is coming in your code, that means your program is actually crashed. I mean, it's not going to move any further. But you don't want your program to crash because you want it to keep running by keeping all the conditions and possibilities in place. So Harry in dictionary 1 is not present. So you can say that if Harry in dictionary 1 or if I in dictionary 1 is equal to blank or not present, or just say if this I of I is in dictionary, it's going to return you all the true and false, and you pick up all the values which are true. Let's see this, how we can do this. So if Harry in dictionary, then you print Harry age. If Tom is in the dictionary, then you print Tom age. Now this is happening because there are two statements running, so only the final statement is going to run for us. So what we can do, if you want to really type this, you will have to get this print statement outside this, and we can get this printed. Harry, if Tom in Harry, okay. Dictionary of 1, if dictionary of 1, we have Harry in dictionary 1, right? So we say that you get this key if we have key error Harry. I think I have not run the dictionary one. Just give me a second. I will run it from here. Okay. False, and then I'm going to get an error. Okay, so Harry in dictionary. Okay, key error Harry. So, okay, just give me a second. Insert this cell above and say, okay, so Harry is not present in our data. That's the reason we are getting that key error. I was hoping that the Harry is available because Harry is actually a false in line number 11, so I should not think about that. But so we do have Harry as a key error because Harry is not present. We simply have the Tom and the Mike. So if we simply go with Tom, definitely it's going to return us the value. So the reason here is what I wanted to say is Harry in the age, you print this. That's the reason we are getting this key error because there is no this guy present as Harry here. And here we're not getting the error because it's actually in the if statement. It's already in the conditional statement of if. So if handles all that part. But when directly we try to put the Harry age, this is not present. Definitely, this is going to run for us. So it's going to give us the Tom age and it's going to give the whatever. We can run this way. Tom age and it's going to give us a Tom age for both the cases. So if it is not present, it's going to give an error for that. Yes, you can do that. In fact, there are a couple of questions which are coming on. Can we give an input from outside? Can we give an input from outside? So there was a question about the input text. Then there's a question about Bobby that can we use input function to get input from console. See, I'll try to clear up things for all the people who are here. See, we are trying to learn the core part of Python core, which is can be used for business analysis. It can be used for data science, for scientific data research. It can be used for general purpose programming. It is already being used for data science and machine learning, which we're trying to learn. But ultimately, what we are learning is all backend. Okay, so let's say if you upload an image on a web page and you submit a button saying that tell me whether this image is Tom Cruise or not, what do you think is going to happen? The image is going to go in the backend in the web page. It's going to actually talk to the Python engine, which is in the backend, and the Python is going to read that image and it's going to say, okay, this doesn't look, the image is not like a Tom Cruise, so it's going to give you true or false, correct? Just same as what we get true or false here in the Jupyter notebook. So when you say, can we pass an input, that all will come from the front end. So if a user has a form where he's putting in his name and all the information, and when he says submits, the information will go in the backend. It will touch the Python engine. It will compute in the backend, and whatever relevant results the user is expecting, that will be thrown back into the variables, and the print statements is going to pick those variables and going to print it in the specified format or in the specified design the way we have done it. So that's going to be an advanced part of machine learning wherein we learn how to deploy these machine learning models over through a web-based applications, because nowadays everything, even the mobile phones, you see everything is embedded applications, right? They're all embedded, full of Java, Python, AI, ML, all these me and all those applications, they are indeed backed up with the AI and the ML embedded codes in that. So that part is different, but yes, definitely we can use input function to get the input from the console. And that's the ultimate goal. When you say submit on your mobile phone, it is like an input, right? My channel in keyword can be used to check if any of the dictionary has a specific key without scrolling 1000 lines of code. That's correct. Thank you for helping that part. So yes, it's going to help you with the values for the keys. So using the get method, let's see what is this. So the get method on the dictionary can be used to fetch value corresponding to a key. So I'm going to say that from the dictionary one, you get me the value for Tom. Now you would see that if previously we learned about writing this differently. So we can say take one standing bracket, and this is Tom, let's say, okay? And you can see we can get the value here as well. Can we get the value for the mic? We can get the value for the mic also. But why do why do you use the get method then if we can get it this way? Why do you have to extend my code and say, like dictionary1.get? What are the methods available? Let's see. So we saw the methods available in the list were something. Here also you can see there are certain specific methods available. In dictionary, we can actually clear the contents of the dictionary. This is like removing all elements from a list and making it an empty list. Clearing the contents, copying the dictionary from the keys, get, this is what we just saw, get keyword or method. Items, get me all the items from them. Get me all the keys. Pop, we know, pop the specific item. Set default, update, values. We're going to look at this, the popular ones. So when we say get, what's the usefulness of get? The get handles an additional parameter, which is called as returns the value for a key if the key is in the dictionary, else default. Can you see this? This is just like taming our if then else function. Now, let me tell you guys, for people who are new to Python, as I said before, every problem statement you will try to solve using if then else. Okay, I'll be very honest. And you can try it yourself. If a small problem statement is given to you and you have to solve that using Python, you will try to solve that using if then else statement always. You are free to use that, but there are other methods also available than if then else. We can use this. So you can say, you can definitely knit this into a for loop or if statement that if the key is present, then you print the key or the values of the key. If the key is not else, if it's not present, then you give me something else. See, for loops and if then else conditional statements are time consuming and resource intensive operations. Okay. So it is recommended that you use methods which are faster. So let's say print dictionary1.get Tom. So the get method accepts an additional parameter to specify a default value in case the key is not found. So this prevents the code from actually crashing and returning a fatal error. So definitely we can use the get method onto that part. So let's see this. So we have a dictionary present here and we have the Harry's age. I'm going to say get Harry. If you don't find Harry in this dictionary, then you give me a -1. That is just any value I have written here. -1, it's just any value. So let's say print of Harry, it's going to give us a -1 because it's not present. Harry is not present in this particular get method of that dictionary. Always take these structures as individual entities, firstly. So list is an individual entity. Tuple is an individual entity. Dictionary is a different entity altogether. So when we have dictionaries, what we can do, we can create a key, we can create a pair. You will also see the usefulness of dictionaries as we move forward, that what kind of data we can store, and you'll really be amazed to see that. So the second parameter accepted by the get function is return the key specified. This allows for a graceful handling of potential error conditions. So I hope now this is being clear that if you don't have the key, you can put this into a for loop also, right? So you for I in dictionary1.keys get the values for the key. So how would you put that? Simple for loop statements. For I in correct. For I in dict.keys, and you're going to move forward like this. I've given you the basic code. So for I in dict.keys, print I. If you do that, it's going to print all the keys for you. And you can get your exceptional handling also out here. So you get if for I in dict, you I.get, you can do I.get, I and the value, something like that. So you can always use these kind of codes for better, for less of resource intensive codes, basically. So Aditya has a statement. Yes, absolutely, Aditya. So depending on data structure of variables, different methods are available. Absolutely. And that is what I want everyone to understand, because once we understand that part, things will become easier. So you will not get confused whether do I have to apply sort on a tuple or I have to apply sort on list. Okay. And if you know that tuples are immutable, so you cannot definitely apply sort on that, or you cannot apply replace on that, or you cannot apply append or extend in a tuple, correct? So you know the fundamental difference. Now you know, okay, on a list I can apply an extend, I can apply remove, I can apply append, insert, pop, all those things, because you know how a list looks like. Similarly, now you have come to data dictionaries. We know how the format of dictionary is. It has got the keys and the values. Then can we have the keys, repeat keys? Can we have the repeat values? Those things we will see as we move on to this part. I'm going to show you that. But we know that if it's a dictionary, then it has to be, the values needs to be passed in a specific format. And if I pass the values, if this is the structure, then these are the methods which are available into that. So dictionary one is Tom and Mike, print before and delete dictionary Tom. So we can say, after we drop the Tom part, we just have the Mike, which is actually present. So the operation modifies the original dictionary, and dictionary one in this case is no longer has a key Tom. So that means this is in place. In place is already mentioned in the dictionary, so it gets modified then and there. How do you pop the values? Okay, we also fetch a key and simultaneously remove it from the dictionary. So how do we do that? So we have dictionary one dot pop. You pop the Tom. Okay, that means you pop, Tom is the key. We cannot pop a value because values can be the same values across the keys, right? So you always go with the key, because without the key you cannot unlock. So you have to go and find the key, and then you can unlock whatever values you want to unlock. I'm going to say you pop the Tom as a key. Okay, and let's see. When we pop this, what this code is going to do? So this command, it will pop the key value and store it into Tom age variable. And when we're going to say you print this, definitely the Tom is not going to be there. But when you print Tom age, this one, the value of the Tom age 42 is going to be there. Simple. So the first one has got two keys. The second one, we dropped one of the keys. And when we drop the keys using the pop method, we did not let that pop function go waste. So we know that the pop is going to remove the value, but also going to give us the value. So when the value was being returned, we stored that into a variable called as Tom age. I hope things are becoming clear, right? So this is what, and the same operations we saw before also. There's no difference. I don't have to specifically elaborate from dictionary point of view. We can see that the original dictionary was modified, but we were able to pop out the age. This popped out value was returned by the pop function, which was assigned to the variable Tom age. So working with the keys. Okay, so I hope that part is clear. Moving forward, simple things. We can fetch all the keys of a dictionary by using a method called as keys. You saw that, right? What kind of methods are available? Keys are going to be, sorry, I was typing distinct. So the key, you can see we have the keys and the values. So if I say you get me the keys, it's going to get all the keys for that dictionary. Since the Tom got removed and it wasn't in place, so Mike is only present in this dictionary for us. Okay, but here we have created. So here you can see. So dictionary again got created and we got the key. where are where are we using this? Okay, I'll give you one example. I won't give you a business example, which I can give you, but still I will not give you a business example. A technical example. Okay, so when you go to Python and start with your machine learning codes, okay, when you're going to do that, there is a library in Python called as an sklearn. Okay, you must have heard about that or even worked on that. So sklearn is used for machine learning. Now, apart from getting all machine learning methods in that library is also supported with a lot of tools. Okay. Um, I'm not sure if how many people have looked at the cloud. Even on the cloud infrastructures, we have got a lot of tools available, which you don't have to, kind of develop at your end. It is already available and you can use it for free. So in sklearn, we have sklearn.datasets, wherein there are a lot of datasets which are available for you to practice, from with financial datasets to economic datasets to healthcare datasets. Anything and everything is available there. And I would recommend you to start exploring those datasets. And that's what, in fact, I did when I started my data science career. I started to explore all the datasets because datasets is going to help you that what kind of data formats you can expect. We got to learn, okay, we got to do dictionaries using integers or something like that. And when you went on to your actual project, the data was completely different. The data set was different. You couldn't handle the factored levels of data. You could not handle categorical data. You could not handle other types of data. So how would you do that? So explore the data sets. And when you explore the data sets, I'm sure that you would not be able to open that data set. The reason being that all the data sets are stored in the form of either list or they are stored in the form of dictionaries. So you have to first get those data outside the dictionary formats, which is given in the data sets, and then create a data frame out of it. So the data frame takes a lot of space and resources. So in order to keep things simple, they provided the data in dictionaries, which is much faster, and then you can convert that into a data frame. Coming to an example of a dictionary like a Facebook. Okay, so Facebook has, you can think of regions being the key. So if a person is trying to locate someone from a particular location, then with the help of the key that can be identified. Same goes with the tuples for that example on that matter. Yeah, we're going to see that. Can you, Nishika, these sessions are for beginners and for intermediate. But yes, I am talking about more from beginning perspective because people out here have a lot of beginning level questions. Bobby, will pop in dictionary will not pop out any key value pair from last. No, it's not going to pop out any key value pair. It will simply pop the value for that key. What is the difference in pop and pop item in dictionary? We're going to see that. I'm going to show that in just a moment, Bobby. Okay, so I hope this is clear. We can go with the working of the keys. Let's see this example. We have got a dictionary. For key in the list of dictionary keys, print the key and the dictionary for whatever the key is. So for the key in list of dictionary keys. So that means this particular key variable is going to have a list of two values. One is going to be Tom and the other one is going to be one is going to be the Tom and the other one is going to be Mike. Correct? So once this key has this value, so your first I will become Tom, second I will become Mike. So for Tom in dictionary, print the value for Tom, and here the print the value of Mike. So here the value is going to be Tom, whatever the age value for that. I'm not sure about the value. No, Mike also works or whatever. See that. Correct. So I can cover this. You can see that we still have 42 and 38. So this is like your iterating. So now this shows, first thing what this shows is key in dictionaries. This example shows, this example is a demonstration is a demo to showcase, correct, that dictionaries are iterables. Sometimes when you're trying to use a for loop on some of the objects of Python, there's going to be a statement that the object you've chosen is not iterables. Okay, means that it doesn't allow iterating over, but dictionary does allow, because you saw that we have applied a for loop for the keys of dictionary. So that's a good news. Same goes with the values as what we saw with the keys. So whatever object, dictionary object dot values we can do, or dictionary object dot keys. So in any of the scenarios, we need these things. So we can see list of values for those dictionaries. You print those values and give it those values. Okay, merging dictionaries and bulk updates. So we quickly go through this. We can merge a dictionary into another dictionary, and this is a useful append with values. So you can see that the dictionary 1 and 2, we saw that for the list, right? So let me just insert a block here. So I'm going to show you, insert the cell below. And so is it like, are we printing these values for, you can see that we are simply printing dictionary 1. We are not printing dictionary 2. So we are saying dictionary 1 dot update. Now, there was one of the lectures I was taking up. So there was a slight confusion to people when we actually use these in tandem. Okay, dictionary 1 dot update and then dictionary 2. So there's some people assume that we are updating dictionary 2. Okay, because dictionary 1 dot update dictionary 2. People are not reasonable in understanding the language, so they think that this is going to update dictionary 2. And same goes for the list and other things. So for people who have these kind of confusions, I will try to help you out in that. The method, see, from the object, so let's say this method, update method, you have to see this update method is pulled from which object. And whichever object this method is pulled, the result is going to be applied on that object. So this is dictionary 1 dot update. That means I'm looking for dictionary 1 to be updated by dictionary 2. If it would have been dictionary 2 dot update, if it would have been this way, then I would have expected the values of dictionary 1 will be updated in values of dictionary 2. Okay, so please bear this in mind. And when we do this, you can see now we have all the 4 keys with us. Rajiv has a question. How much data can we load in a dictionary or list? Actually, Rajiv, that's a good question. And I will say that the big data, actually the big data got an edge because of these kind of data structures. Because you have a flexibility now to store really large amount of data in dictionaries. All the LinkedIn connections which you see are based on dictionaries. All the Facebook connections which you see are based on lists and dictionaries. But lists and tuples or vectors is already a part of dictionary, because I showed you the first code wherein the 2 values for 2 keys we had was, one was list and the other was vector. So there is no specific limit as such, Rajiv, that how much data we can store. They can handle a really large volume of data. And the only thing is that if you can afford to store large amount of data into your dictionaries, you should also be able to afford that kind of hardware infrastructure to process that kind of data. What I mean that if you've stored like terabytes of data in dictionaries, then definitely you would need a powerful machine to process that data. You can't simply work on a smaller given machine and expect a real good results. You will definitely need to scale up your hardware. We can see that the operation modifies the original dictionary and dictionary 2 remains unchanged. So the function is called update, and in many scenarios, it is used to not append the dictionaries. but to actually perform a bulk update of values on an existing dictionary. So now bulk update of values is again like we can have many different dictionaries values which we have inside that part. So very good part. Dictionary one is this, and the dictionary two is this. Is there any difference? Yes. So dictionary one dot update next year and print dictionary one. So let's see what's going to happen. You can see this. So update is not an extension. Okay, we can see Tom is this, but when we have the new values, actually concatenated that. And I can definitely go back and do the update. There's one thing that now if I update any changes in dictionary 2, that may not reflect in dictionary 1. So these are a couple of keywords. You can try this permutation. You have to be, so the reasoning has to be very strong. Uh, mm, what is reasoning? People, when you work on software systems, you need two things. One is data interpretation, and second is data reasoning. Okay. I feel the kind of people we have in the session, all are they have a good reasoning, because I can see a lot of questions coming up on the panel. So definitely, I would rate you a little higher when it comes to your reasoning, because reasoning is all what makes all the difference. So how to update data into another dictionary by sorting out before updating. So you want to sort the dictionary and then update it. So simply first use the step of sort, which we have in the dictionary, and then use the update. Roshali, how to load ready-made data into dictionary? Yes, we are going to do that, Roshali, very well. And I'm sure most of you are very excited to see how the real data is going to flow inside these data structures and how we're going to make a use of that. How do we make not use of that, but how we can make that useful? So the purpose of being a data scientist is not to use the data. The purpose of being data scientist is to make the data useful. That is what the overall goal for data scientists should be, because data scientists' job is not to just apply a simple regression, but the job is to tame the data in a manner which is most reasonable for data analysis. Okay, so please keep this in mind. And we will definitely load ready-made data into Python, and we will see how dictionaries are able to handle ready-made data, how other structures are going to handle. So understanding key and value types, a dictionary can essentially store any value. Anything that is an object in Python can be stored as a value in the dictionary. So that is a good thing. That means you can also store lists, tuples, sets, or any other structures. This includes the fact that even functions can be stored as values. So that's absolutely good. Keys of dictionaries can also be any object type, but only as long as the object is immutable. I hope this is clear. You can read it at your end. So the keys of dictionaries, they have to be immutable and should not be able to change ever. Okay. Because if the key is changed, you can never enter the house. A mutable object cannot be stored as a dictionary. So let's look at some of the examples. Can you see this as the first example? Now there will be another question that can we also give keys like this? Yes, we can. In the form of, like togetherness. So Tom and Mike, and then we have the two values for Tom and Mike, and then the two values and the two values. You can see that the key is given in tuple in a vector form. This is also given in the vector form. And this is given in the vector form, and this is given in the list form. Now, firstly, whenever you create this, it always specify in a vector form, because by will, you don't want the keys of dictionaries to change. Because if the keys of dictionary change, then you will have to do all the rework, and which no developer would like to do it, or no analysts or data scientists would like to redo the work. So dictionary one dot update next year. I am forgetting what are the values for next year. Okay. Okay, so let's look at this one. There is a question, please discuss and describe how functions can be stored as values in dictionary. So I'll tell you one thing for this. I can definitely show you that, but meantime, what you do, you can copy this code, and this would be your practice, and absolutely will know about that part. Just copy this code, and instead of you writing 42 and 38, you write any two functions in this. You can write a sum function here, and you can write a length function here, and try to run this and see if it is running or it's giving you any error. You can update me, and it's going to take just a minute. So let's say dictionary one dot update by next year. So you can see that Tom is 43, Mike is 39. So firstly, it's going to try to upload change these values. Do you think that will allow to do that for dictionary? Let's see. Okay, great. You can see that 42 and 38 still remains 42 and 38. But when you try to upload the Tom and Mike, which was actually individual keys in the dictionary, they got extended into this dictionary individually. They did not actually change this to 43 and 38. If this next year would have had Tom and Mike specified in that manner, definitely the update would have worked for us. But instead of updating existing values like Tom and Mike, which was actually like a tuple, it did not do that. So in the above example, Tom, Mike is the key of the dictionary. In the second record, we have an array. So this is the key which we can never change, because firstly, this is a tuple. The values for this also we cannot change because this is a tuple. This cannot be changed, but this can be changed because it is a list. Rajiv, your question is too technical. I'm not sure if I'll be able to. So we have what type of sort algorithm? So we know we have got 4 or 5 different types of sorting algorithm, right? Internally, we will have to go a bit onto the machine level and check. We can very well find out that. That's no problem. But it's just that it might be it will be out of what we're learning. But yes, Rajiv wants to know what kind of sort algorithms we are using in Python. So by default, we are using the breadth first search, those things, the LIFO and the FIFO parts, which we have studied. Correct? You must have also studied that part in our C++ classes. So those algorithms, but I'm not sure certain still which specific algorithm is being used in this. That we'll have to find out. And is it possible to tell Python to use any other sorting algorithm? I'm not sure about that, Rajiv. I will have to find that. I can find and let you know about it. And we can discuss it in tomorrow's class, what kind of an algorithm we are using, the sort algorithm. And that's a good question by Rajiv, because sorting is the only operation which is the most expensive operation in the whole of the computing operations. Sorting is actually very hardware intensive and cost intensive activity. And if you have like billions of records, and if you want to sort it, that's going to be the computer, the kernel is really going to have a hard time doing that part, but still the computer does it gracefully. Okay, so in the above example, Tom and Mike is the key, and in the second record we have used an array like 40 and 36 instead of a tuple. We can use 42 and 38 as a key, but we cannot use 42 and 38. This list of 48 is a key. This is because the first is used as a tuple, and tuples are immutable. But the second is a list which is mutable. So I hope this is clear. But there are a couple of things which I also want to address. So let's say insert cell below. Just want to highlight one thing. So let's say I have my underscore dictionary, and I want to create a dictionary called as Mike, and there are some values to Mike. Let's say 3, 4, 5. Okay, and this is what we have created. And then there is another one. Let's say Josh. This guy is Josh, and he has like 4, 5, 6. Okay, now I want to tell you certain things which I wanted to tell you, we have, um, let's say Robin, and he's got some, like say 5 6 concept. Okay, I hope this is a dictionary which is created, and I can definitely do my underscore dictionary, and it's going to give us these values. Now, a couple of things from my side. Last on the dictionary, only 2 things. Can we have the values repeated in the dictionary? Okay, we can try that. So say we have these Josh as 4 5 6. Okay, can I have it here? 4 5 6. Okay, you can see that you can have the repeat values as your whatever structure you have in this way. Or if you want to, um, this is like, say his name is Mario, and the value for this one is 4. And there is a guy, like say priest, his value is also 4. Okay, you can see that we can have both lists with same values as repeated values in the dictionaries. We can also have scalars like 4 and 4, which is given in the list. It's already, we can keep those values like that. But let's see what happens. So values are completely independent of each other, right? But let's see, can we have the same approach for the keys? Okay, no, I don't know. So my dictionary is equal to, I'm going to create a new dictionary, and this guy's name is Mike again, or let me just copy the same thing. Why should I? Okay, here, and we'll make some changes. Let's get rid of Mario and priest. And let's say we have a Mike here. Okay, that's great. My underscore dictionary. You can see what has happened. A dictionary has taken up only the last occurrences of the key, just like our print statements, right? So when you have A is equal to B, when you have A is equal to, I have some values of A and B, right? A is not different. Okay, so A is equal to 3 and B is equal to 5. So when we have this value, I'm going to say, you give me A, it gives me A. If I say B, you can see it gives me only the last value, correct? So same thing happened here also. When it wanted to traverse to the dictionary item, when we have this Mike and Mike as the same key, it's going to pick up the last one in the instance which it found. Okay, so this was the the least what I wanted to tell you today, but there are many other things that we can look at. All right, so any questions in dictionary? There are something. Can we import data from a CSV file? Yes, we can do that. Snigdha says only the list can be changed in the dictionary, not a tuple in this example, right? Absolutely. Let me just scroll to that example. Yes, this one. We can also provide 42 and 38 as a key, which is already been said, but not different. We're not going to do that. We always try to keep the key as characters. And you're right in this, Signa, that we can definitely change list in this. So that means we can change the values of 40 and 36, but we cannot change the values of this tuple. Okay. Could you please change 42, 38 as sum and length as discussed to show how functions work here? Okay, let's see that. So let me copy this dictionary. Okay, and you're saying that you would want to use sum here and you want to see length here. Let's see. Okay, and then take one. Could you see this? That it actually can save your functions also. So the text which we had seen before is actually true. Now, from the functionality perspective, this really sounds awesome that, okay, we can store functions also as values. But what is the usefulness of that? So we will have to see an example, correct? So we'll have to see an example in order to understand the concept. So whatever examples we are looking at these notebooks, it is supported by concepts. There are a couple of questions coming on the screen for me, which is asking varied type of functionalities in Python. And rather than simply talking about it, I would want to give an example so that we are all on the same page. So things which are easily manageable right now with the stipulated time, I can write it down for you and I can try to show you some differences. But for things like which are difficult to write, because you have to think, right? When you write, you have to have your focus. Whenever you write your code, you have your focus to write it. So we'll try to see how it works. So I hope this answers your question. School fun. I hope this is Supreet, if we have multiple values as an example, like Mike, count of each value, it's pretty simple. So you can just take dictionary one, length of dictionary one dot keys. You're going to get all the count for all the keys. Sure, school fun. Thank you. Snigdha says, thank you. Thanks, Snigdha. Okay, so I hope you're able to understand what's happening now. I will repeat it again as I started in the start of the lecture, that now please do not confuse yourself with the sorted method, sort method in dictionaries or sort method in list, or maybe an extend or a pop methods, basically in your things. So every object has its own purpose, and every object, whatever purpose it has got relevant methods available in that purpose. Okay, so please, you can refer the help file. Priyadarshini says, can we extract the abstract from the PDF using dictionaries? Sorry, Priyadarshini, it should be the other way. You can extract the abstract from the PDF, but not using the dictionaries. You can extract the abstract from the PDF by using some other tool and then storing those results in the dictionary. That is a more regular way of doing it. Ishan Kumar says in line 39, key is Mike and values array. And value is array. No, actually, this is a set. That's a good point, Ishan. I was actually expecting people to ask, but this was the last question. This one, yes, this is not a dictionary. Okay, so I purposefully wrote here so that the question should come from the crowd, and indeed it did come. Ishan, thank you. So Mike, I have used this curly braces not to define that there is a object dictionary only. So this is a key for the dictionary, and the values is not a dictionary. This is a set. This is a list. This is also a list. This is the keys. These are the values for the keys. Again, the keys and the values for the keys in the form of lists. I hope that answers the question, Ishan. Please explain diff and pop and pop. Okay, I'm going to do that quickly. And last question for dictionary, guys. We're going to switch on to the other book. So I have my dict one dot pop item. So remove returns pair as a two tuple, key and the value. So what is the difference between pop and pop item? Remove and returns a key value pair as a two tuple. So that answers the question. Bobby, what is the difference between pop and pop item? So pairs are returned in LIFO mode, last in first out. Okay, order. It raises a key error if the dictionary is empty. You see this? Just exactly what we saw in the in the documentation. You can see pairs are returned in the last in first out. So Harry and Alice was the last major ones to get in, correct? And they are the first one to come out. Last in first out. They are the first one to come out, Harry and Alice, and the subsequent values which we have for them. So here it says, so remove and return. It removes and return a key value pair as a two tuple. Pairs are returned in LIFO, raises key error if the dictionary is empty. I hope that answers the question for you. Now, see again, I just did it technically. I showed it to you technically, but yes, where is the usefulness of this? We'll definitely try to. I will try to knit this up so that we are able to understand these things better. Why only the last value? What if I want the previous two values? What to do? Maybe we can use some other option for that. I hope that answers the question, Bobby. So people all good. I hope we are comfortable. It's been 1 hour that we have started the lecture. I hope we are not feeling sleepy. I hope you are still concentrating. Only if it makes sense. Because if I try to if I bore you, definitely it leaves no room for you to do anything else except go off to sleep. But yes, I don't want that to happen. So let the session be interesting. And one more thing, that as a trainer, as an instructor, I just don't want to keep talking. Yes, your questions do motivate me. Your questions do encourage me to do this better and show you more examples, so that eventually we are all on the same page and try to understand these concepts. As BlobCity said sometime back, that these concepts are really important. Even if you right now, if you kind of shiver in writing the codes, it's okay, but you have to frame your structure completely in your mind. The flow of the program should completely be on your mind, and later on you can bring it physically on the canvas of your code, and then try to work around for some more exception handling over that part. But yes, the first thing is to logical understanding. When I wasn't a programmer, and honestly, in today's time also, I don't code complete. I have developers who actually code 12 hours in a day. I don't code 12 hours in a day. But the part is the fundamental aspects which are already available to me is helping me not just sharpen my skills and the existing technologies which I know, but it also helping me to learn new technologies and understand them better. Because there is nothing which can go beyond 1 plus 1, right? So if 1 plus 1 is giving you 2 as a result, nothing can change that. So similarly, if we understand these Python fundamentals, nothing can change that. And the only thing is you may just have to keep updating as you move on. Now, sets are another data structures which we have in Python. And this is the set which I tried to pass value as into our previous example of the dictionary. I passed a set value in that, like using the round brackets. Sets are also created using the curly braces, not round, sorry. It is created using the curly braces. And so there are 3 parts in sets which I will tell you as a thumb rule. Firstly, sets are created using the curly braces. Secondly, the items in the sets are all unordered. They don't have an hierarchy. You can never sort the items in a set. Third, that sets cannot have duplicate values. Okay, you can relate this to a very boring example of probability in mathematics, maybe in our 7th or 6th or 8th grades. That imagine there's a bag of balls wherein 10 balls are white, 5 balls are pink, rest of the balls are of other colors. And I'm sure still a lot of people after looking at that question finds it very boring. Yes, of course it was boring that time, but now it is interesting because we have understood the reality. So the sets are also like that. The only thing is that the balls which are there in the bag, firstly, they are unordered. There is no sequence to them. And secondly, none of the balls in the bag are repeat. Even if there is a repeat, we have manually removed them, just assuming because it is not working with Python. So in Python, whenever we're writing a set, the values in the sets are all unique. So they cannot be repeated in this case. Now, I will tell you the good example of sets, how we use it from business perspective. Technically is fine, but also in business, I will give you a small example, which will encourage you to explore sets further. So a set is a collection of unique items with the structural implementation of set not allowing to have duplicate values inside the block. A set is defined by the curly braces. So set one is equal to curly bracket of 1 comma 2 comma 3. This is actually a integer set. Print of set one is going to give us the value. We can initialize a set with duplicate values, but a set will only retain unique values from the one specified. Here is an example. Let's look at this one. So set one is equal to 1 comma 1 comma 2 comma 3, and the print of set one is going to give us what? Only 1 to 3, because sets can never have any duplicate values. The above example shows that we try to define the set with number one being repeat. However, the output shows the number was saved only once and the set stores only unique values. So this is one rule that we have learned. It is important to note that set does not give any ordering guarantees. So in the above, all the three of them refer exactly the same set. I mean, honestly, now set is another structure compared to dictionary and list, and sets will have a different type of methods. So that means if sets cannot have ordered elements, so we cannot have a method of sorting in sets. Secondly, if the sets cannot have duplicate values, so we cannot say remove duplicates or something like that. So definitely these methods will not be available for a set as an object. So whatever object we are working on, all the methods are relevant to that object. Add an element. We can add an element to an existing set by using a method called as an add. So you can say set one dot add two and add four or something like that. So when you say when you print the set of one, you're going to see the value as 1, 2, 3, 4. Because we try to add two, but set did not give us any kind of an error message saying that if the set has already got the value of 2. No, since set is going to consider that as a unique value, it will still input it without raising any errors. Because if it tries to do this way, then every now and then we're going to get errors. So print set of 1 is 1, 2, 3, 4. It's very simple. We can add element inside a set by using a method called as add. How do you find an element? So far from the past 3 workbooks which we have been coming up is, okay. Sorry about that. I lost the track. So yes, finding an element of the set is, we have some sets with us, okay? Sorry, we have a single set with some values in there, like 1, 2, 3. So contains, and as you said, as we have seen in a couple of notebooks earlier, in order to find the most relevant word, we are using a keyword called as in. By the way, I wanted to give you a list of all the keywords, which I will give it to you tomorrow. So you can just see what kind of keywords are available. So in is also another keyword. So contains 2 in set 1, contains 4 in set 1, etc., etc. And when you try to run this, it's going to give you a Boolean output saying that, yes, it is true or false or something. Okay. Okay, all right. So whenever we're using in is like asking a question, correct? It's not about defining an instruction or giving any instruction. Yes, simply saying that you find out if it's there. And if it's there, then you tell me whether it's there or not. So that's the reason computer does tell you about true and false. Remove an element. We can remove an element from a set by using the remove function. A remove operation modifies the original set. So again, we have a set of 1, 2, 3. Set one dot add, the way we had done set one dot add. Similarly, we have set one dot remove. Now these things we are doing manually, but when you actually write a deployable code, all these condition needs to be analyzed. There's a reason you need a planning for building your software. Then after that, you need a testing team. You can use any of the softwares to test your system or applications with all the kind of test cases that you can feed in. We cannot attempt to remove an inexistent element. The operation will return a key error. If specified, we can remove it. So let's say 2 can be removed. Let me run this part. And you can see that the 2 is eliminated from the set of 1, 2, 3. All right. And same, so we cannot remove an element which is not present in the set. So when we try to do this, it's going to give us a key error, just like what it gave us before. To prevent an accidental key error, we can always check to see if the element is present or not. So you can see that we don't have any exception to give here, that if you don't find the key, then you basically give me -1 or just give me a text saying that key not found or something like that. So set 1 is again 1, 2, 3. And if I'm saying if 4 in set 1, then you remove it. If it's not there, don't give an error as such. So it didn't actually give any error. It simply gave you the set 1. If 4 would have been a part of set 1, it would still give 1, 2, 3 because it will eventually remove 4 for us. So how to create a set? Okay, this is what we have seen. Now I'll give you a real example of a set. You can consider set as I told you, a bag full of colorful balls. That is a set. You know, you can take up like say for Shoppers Stop. Okay, there might be some customers who have shopped with them in 2015, and there would be some customers with whom they shop in 2020. No, sorry, not 2020. Nobody shopped. 2019. So 2015 and 2019. So we have a set of customers with us of 2015, and we have set of customers with us of year 2019. What kind of operations can we do on these sets? See what kind of business questions you can answer from these two sets. First question: give me the people who shopped with me only in year 2015 and did not shop with me in year 2019. This can be very well achieved using sets. Okay. The other one is give me only those people who shopped with me in both the years in 2015 and 2019. It's actually an intersection. This is again can be solved using sets. The third question: give me only those people who shopped with me in year 2019 alone. So you can see that 3 questions have already been answered by using sets, and there are many other questions which will be answered using sets. So those are like examples which we're using sets. So instead of these sets, what we see on the screen having these numbers like 1, 2, 3, 4, we will have customer names, we will have the transaction values for them, or we can have any data which can be seen as a collection. Okay, that is what we will have here. Pop an element from the sets here. You can see, and I think everything is now simple for you, because now you know what is pop, you know what is a pop item, you know what is reverse, you know what is sorted, you know what is extend, what is add, insert, sorry, what is insert, you know all these things. What is add, you know, what is remove, you know. Let's say pop an element. So for a in the range of length of sets, so that means whatever the length of sets you have, you run those many iterations. In this way, the for loop will never be out of iterations. Because if you try to say for a in range of manual range, if you give here, if you give a manual range 0 to 3 or something like that, what if your elements in the set increases in future? And you will have to come back and increase that range. So it's better to use dynamic programming syntaxes. This is called as dynamic programming syntaxes. The moment the length of the set will change, or the items in the set will change, your for loop will also run those many times. Okay, that is because of the range of the length of set. Print pop and set1.pop. So pop is going to remove a specific item for you. I'm going to, so we have 1, 2, 3, and we are saying that you give me, you actually remove all. So this, what this guy is doing, it is removing all the items making set empty. Okay, making an empty set. Okay, it's going to completely finish the set. Pop 1, pop 2, pop 3, set 1 set. A pop operation will result in a key error if invoked on an empty set. So if this set is already empty, and if we try to run this, okay, I'm not sure if it's running now, so but if we try to run this, it's going to give us it empty. So you can see this. If we have set 1 with a single value and we remove that value, and then again when we run the pop on that, it's going to give us an error prop from an empty set. Okay, in this one, for a in range, whatever length of set 1, let me say I want to print insert cell above. Okay, this is also an empty set. So set 1, yeah, set 1 dot pop, and then this should give an error. Basically, maybe I have to run it from the start. Sometimes it happens in Jupyter. It doesn't give you the code what you expect because of mismatch. Okay, not a problem. But let's see from this example, if we have already vacated the set, means all the elements are removed, you cannot rerun that. As simple as it. You cannot empty a set which is already empty. Now, coming to those examples of what I spoke about, customers of 15 and 19, can we union those customers? Yes, we can create a union of 2 sets, which creates a new set containing unique elements found across both the sets. So set 1 is 1, 2, 3, and set 2 is 2, 3, 4. And now set 3 we are creating, and I'm saying set 1 dot union. Now again, see, union is applied to set 1. Okay, so that means set 2 will be union by set 1. So let's see set 3. And there's one thing to notice, that repeats are not allowed in sets. So whatever 2 and 3, which is coming as repeat values, are already been dropped. And we have a new set with us 1, 2, 3, 4. Because it absolutely makes no difference to a set. Because in 2015, if I have shopped with shopper stop, let's say 10 times, how does it matter? Because I'm not doing sales analysis, correct? That I need all the transaction values for 10 times. I'm simply doing a set analysis that how many customers actually shop with me. It's a count of customers, not the sales value of customers. So it would not really matter if, Suvir as a customer has shopped 10 times or 1 time he has shopped. That is more important. Yes, he has shopped with ShopperStop at least once in 2015. That is something like that. Set 1 dot union set 2, and you can see the set 3 produced contains the value. The original sets 1 and set 2 are not modified. We can print them to confirm. You can see that set 1 has still got 1, 2, 3, and still set 2 has still got 2, 3, 4. I'm not sure, Sobik, you can please ask the class admins for that. Yes, absolutely. Swapna has a question, calendar or date, also a part of set. Yes, any object can be a part of set, Swapna. The pop has to pop from last to first, but yeah, for here, the first and the last item more or less is the same for the pop. So yeah, there's a reason we have got an empty set over there. So what a unique can also be performed using the pipe operator. Okay, so we can say set 1, set 2, and you give me set 1 unique, set 2. So what is this? Set 1, set 2, and set 1 dot union set 2 both do exactly the same thing. Okay, so I mean, unique can be performed means is even if you union both of the sets, and if it has got repeat values, anyways, that's not going to be considered. So you can say that it's a unique kind of an operation over there. So set 3 is equal to set 1, perform a pipe operator on set 2 and give me all the values for 1, 2, 3, 4. So union, we know what a union does, and I'm sure you also know what an intersection does. So you give me all the values which are intersecting in both the sets with us. So 1, 2, 3, 2, 3, 4. So you give me 2, 3 in that case. So let's say 1, 2, 3 and 2, 3, 4. I'm going to say you set 1 dot intersection with set 2, print set 3. You can see we got only 2, 3 simple operations, right? I mean, and people who are working on SQL would also be able to relate with this, because in SQL we do these kind of operations a lot. We can now see that the resulting set 3 has only 2 and 3 values which were present, which are populated only by the intersections. Intersections can also be performed using a AND operator. So 1, 2, 3, 2, 3, 4, set 1 and set 2. It's going to give you 2 and 3. So both set 1 dot intersection set 2 and set 1 dot set 2 do exactly the same things. So so good part that sets were actually very small. In fact, this is all what we have in sets. Honestly, in Python, there's nothing more to this. The only thing is that you should know how, because the sets do not have ordered elements. Sets do not have repeat values. So there's nothing much left in set to other than you doing union and other operations as we saw, like intersections. So I mean, this is all what we have for people those who are new to this class and oftentimes do not understand the structure of the data will always have difficulty understanding this class. So for people those who already worked on Excel, for people those who have already worked on Tableau and those kind of tools, these things, or even on SQL for that matter, these things would be simpler. For people those who are very new to this class, you have not even seen how SQL works, then I would suggest that you should start spending around 12 hours in a day on these subjects and try to understand all the in and around nitty-gritties, whether it's sets or basic mathematics or it's basic statistics. Correct? Yeah. Absolutely, Ankita. Ankita has a point that in SQL, we do it with tables and records. Can we do it? Absolutely. So you can consider your dictionary as your table, isn't it? Entire dictionary as your table, wherein the key is nothing but the column name, and your values are nothing but the values for that column. So once you convert your dictionary into a data frame, it more or less becomes like an SQL table. And once you have your SQL tables, you can start doing your query and analysis, that you give me only people who have done sales more than X amount. Give me only the seasonal data. Okay, give me only the data which is making losses in specific regions. You can fire n type of queries on your data set. I hope that answers the question, Ankita. Moving to the part like functions. Now, functions are not data structures. Until now, like sets and dictionaries and lists, we saw they were and sequence, there all we saw was they were structures. Functions are not structures, but they are operations performed on those structures. So functions are one of the most important parts of Python. Like any other language, they're allowed to create reusable components of code, but functions in Python are special. They are essentially objects in themselves and can be passed around as parameters. We'll take a look at this in the details. Let's see this. So as functions are defined using the def keyword, they can take in any number of arguments and can return values. However, in Python, functions can return other functions also. We will do that later. the advanced part. So let's define our first function. Def myfunc print hello world. Okay, let's see this. Okay, I've run this particular function, and as you know that whenever we run a function, we basically need to type the function name, and then we have to say the enter. So you can see this. So the first function which got defined was some things, and then we try to run that function. But how did this thing happen? Let's see this. Define means that we are telling Python that we are now defining a func. Okay, this is the first thing about define. What is post that? Name your function. Okay, the second thing is you can name your function. As I said in the past classes, I guess earlier when I started to program in 2008 and 2009, when I initially started to look at the programming, I used to wonder that how computer understands the real names of the world, real world names. Okay. Um, let's say somebody was developing an application on sports like baseball and basketball, and the computer used to print that number of balls in a baseball was this, and maybe in another game was this. And I was wondering how computer is able to understand that this is a basketball and this is a baseball. That is because you name things in your programs. So here also, you can name anything and everything till the time it is falling in the limitations of Python. So that means like you cannot start a function name with a number. You cannot start a function name with the @ or any special characters. All these limitations are there, which is for good. So the second part is to name your function. And if you see this syntax part, or less, and if you see the syntax part for this is more or less the same, just like our for statement. So for I in something, colon. So here also you see define my function and the colon. The third part to this is arguments. Okay, so arguments are placeholders in the functions. Placeholders for variables, let's say. I'm going to talk about this in a moment. Functions, okay. And then the body or the method of the function. You can define what kind of the rest is all our hands, body or the method of the function. What kind of a repetitive task that function is likely to do is what the body or the method we talk about. So here we are saying the first is we have given an instruction to Python that we are defining a function. So please be ready for that. And then I have some name to my function called as myfunc. Right now, I have not given any arguments to this function because I simply want this function to always print hello world. And that's what happens every time I run this and I try to run this function, it keeps giving me hello world. The above statement creates a function. Functions follow the same patterns, what we have seen before. Function does not return a value, but simply prints hello world in this, at least in this function. If we run the above lines, nothing gets printed. However, when we type the function, that's where the function value or the function gets invoked over there. So if I try to use this, it's going to just say hello world. So the above statement simply invokes the function, which results in the print statement of hello world. Now tell me, is this clear? This part of functions, it's very straightforward and very simple. First, define, give a keyword like def. And after that, you define the name of your function, whatever name you want to give. And then arguments to your function, if there are any. And then coming to your body of the function, that what kind of operation you would want to have with the received inputs from those arguments. Now, functions can have inputs into them. So if I want a function to add 2 numbers, I have to at least provide 2 numbers to function so that it may give me the result for the addition. So those 2 parameters are called as arguments. So I can say sum, open bracket, A comma B, bracket close, where A and B actually stands for arguments. If I don't specify A and B, this function sum will never return me a sum of these two values. So we're going to look at the arguments also. Let's say here in the bottom, we can see passing parameters. All right, so defining my func, and you can say instead of we leaving that bracket blank, we are putting that some value. Now again, this value was never defined before, just not to have any confusion, guys. This value was never defined before. So Python has got nothing to do with what the name of this argument is, unless we call that argument later on. But in the initial line of the function where you define, you don't need that argument name. I mean, you don't need a standard names. You can put any name in that argument, and always put the pointed names. Let's say if you have my function doing some like a sum operation, so define the name of the function to be something starting with sum. Your argument is going to be, let's say you have to one pass a larger number and second is a smaller number. So you just type in two arguments, a large comma small, something like that. So absolutely. Akshay has a question. Can we define loops and see? Absolutely, Akshay. So that's what I told you. Sorry if I did not complete that part. I told you that we can write any body or the method of the function, and just to extend it, and it can include from your loops to nested control structures, anything for that matter, you can have it. Okay. And we will see that moving forward, just not by saying it's, I'm going to show you that. So you can see that my function has got one argument. Okay, and that argument is just simply written as name. And this is the most relevant name of the argument given because we are actually trying to capture the name of a person. So print hello and the name. You can see, you can say print, you can say my func as Tom and my func as Alice. You know that when you try to log in into any web-based applications, automatically it says, hello, Suvir, welcome back. Or, when you have your account with some other name, but when you log in, it calls you, or the web application greets you with your first name in the initial, let's say, Mr. Suvir, we welcome you. How does those things happen? Because in just that placeholder of that web page, they have fit in a function. Whichever user logs in, you look up the name for that user from the database when he filled the form, and those placeholders needs to populate the name of that person. And this is not defined for a single person. It is defined for all the people who are coming on that web page. Simple things. So we have a hello Tom and hello Alice. So we can pass one or more parameters to a function. The parameters. So here you can see that the name is actually a function, actually a parameter. And you can simply say you print hello and the name. And when you pass those argument values into the main function, then the main function body gets it gets executed, and that's what we get here. So the parameters are specified in the function and are accessible within the functions. And we know what those above examples do. So to keep in mind that the data type of parameters does not have to be defined in Python. Many languages require you to mention, I think this we have already done in the last sessions, right? That the Python is type independent that we had seen before. So if firstly, if a value is with an integer, it can also have with a Boolean or a date. So that means many languages require to mention the data type, but not in Python. This means each parameter can be of any valid data type. Let's see this. So my function 5, my function 1 to 3 and 1 to 3. So what does this do? Hello 5, hello 1 to 3, and hello 1. So we have successfully passed an integer, a list, and a tuple to the same function. So what does this mean? This means that Python is not accepting, it's not expecting only a single data type as argument. You can pass in any argument. This is the power for Python. You can see, so we can pass in any arguments, um, type of argument basically in that name section. We have successfully passed 3 different data types or structures for that matter. We can also pass any number of parameters to a function, and all parameters can be of any type. So let's create a new function called as print coordinates. And it has got 2 arguments here. If you see, it has got X and it has got Y. I'm saying print coordinates are X comma Y, and you print the coordinates as whatever the value for 5 and 8. So what do you think the output here is going to be? Here, instead of our X and Y, definitely it will be replaced with 5 and 8. You can see this. So the coordinates are 5 and 8. Correct? So you can see if writing a function definition is as good as writing a for loop, and even the syntax and the method is more or less the same. Some people might wondering that why we have so many commas and we have so many colons out here. This is just to make the structure in this way, because if you see X and Y, they are actually variables, correct? They are not the string data. So they have to be defined without the quotes. You can see that the X and Y is actually defined here without the quotes, because we want that their actual values to come in during the print statements. If we cover that with quotes, then it's going to simply say coordinates are X and Y within the quotes, which actually makes no sense. So just to get this variable as an absolute value, we have defined it that way. And since we needed these brackets also, you can see this, we needed these brackets also, plus we needed this comma also. So for cooking up all these things, so many colons were required. All parameters values are assigned in the order which is specified. However, it is not necessary to pass them in the same order. There are 2 important concepts that we need to understand. We can specify the parameter name and then pass the parameters in any order. And this is also simple, but still we have to look at this part. And please be attentive again. Okay, so because when you look at this for the first time, it might be like you say, oh, it's like too much to understand. It's not like that. You have a look at this at least once with me, and you will see that it is so simple. So let's say there are 2 important concepts to be understood in Python. First is we can specify the parameter name and pass the values in any order. Really? Let's see this. Secondly, function parameters can be made optional by providing default values. Okay, that's great. You can see that some of the functions which we explored in the past for list had some default values. Let's say when we were popping out the key of the list, the key of a dictionary, if the key is not present, it gives key error. And then we had to specify the pop item, wherein we can also specify the default value. So that's the way, there's a reason there are 2 different functions created, right? Pop and pop item. In pop, you can only specify the value which wants to pop out. Pop item is basically you will, as I said before, you'll get that difference. So when you want to give a default value in pop item, you can create a function for that. So every time if you do not have a key in the dictionary, it will keep giving you the default values in case if the key is not found. You can create functions on that. Not necessary that you have to use pop and pop item. You can create your own functions with the help of pop and pop item, which will never ever give you error, even if you are unable to find, or your program is unable to find a key in the dictionary. Let's see how this is implemented. What is implemented? These 2 steps. First, we can specify the parameter name and then pass the parameters in any order. Second, function parameters can be made optional by providing default. Let's see this one. So there are 2 arguments to this. Let's see if we can pass the values of y first and x later on. As shown in the above code, we have passed x and y parameters in reverse order, and this is done by mentioning the name of the variables. So I have said, I did say print coordinates of this one. Okay, so you can see the coordinates are 5 and 8. And what was the parameters we have mentioned here? You can see x was first, y was second. But when I passed the values in the reverse order, y is equal to 8 and x is equal to 5, whatever, it nicely printed for that format. I mean, there's nothing intelligence out here for Python to use because anyways, you had defined those parameter labels. And here also you're defining the parameter labels. So Python says, I don't see any room for confusion. So I very well understand that the value 5 is for X and the value 8 is for Y. If you do not specify the variable name or the argument name, then there's a likely chance of Python being confused as far as the order of the arguments is concerned. So as in shown in the code above, we have passed x and y in the reverse order by mentioning the name of the variables, and it seems that it has worked for us. Okay. In fact, in many scenarios, it is common practice to mention the name of the variables even though they are passed in the same order. Actually, I will go with this point, and I think you all should also make a note of these points that whenever you pass the parameter, always ensure that you pass that along with the name, even if you're passing in the same order, because you know the other developers might have that improve the readability. Yes, you can, Ishan Kumar. Ishan has a question: can we use dictionary as a parameter in function? Yes, you can do that. So Python is very powerful that way. You can do it in a single minute now if you are near the system. If you're on the screen, you can try to show and see if what you asked is going to work. So instead of passing x comma y, x could be a list, y could be a dictionary. Let's see that. So as we see, we did not have to specify the value of y. By skipping the y value of y, we got default to 0. So let's see this print coordinates. 5 comma 6, we are assuming x is 5 and y is 6. So simply it's going to print in the same fashion. We can create a function with all parameters of the function have a default value. You can see this. So define print coordinates, x is -1, y is 0, print coordinates x and y, print coordinates 5. You can see this. So one of the values which is going to come is going to be 5 comma 0. Have a look at this code, and if any questions, please ask me. I hope this is clear, right? Is this clear? Do you think this is enough or you want to see more? Yeah, is this clear? Okay. Now you can look at the code and you can understand this part, how it's working. So here you can see that we passed a single default value to y. Here we have passed default values to both the parameters. So when we are passing a default value to y, definitely in this case also we're going to get 5 comma 0 because we just passed the parameter value for x, but we did not pass it for y. Let's see for here print coordinates 5 comma 6. Now this is not going to give 0 as a y value. It's definitely going to give you 6 only. So coordinates are 5 comma 6. We can create a function with all parameters of the function have a default value. So print coordinates x -1, y is 0, and you give me this. So here also 5 comma 0. If you say, let's say only print coordinates, okay, you say print coordinates only as a single function, you can see that if you don't pass any values in parameter values into the print coordinates, Despite having two arguments over there, it's going to return you the default values over there. You can see this. Same here is being done. Print coordinates, you can see the default values which are coming up. So we know that x is -1 and y is 0. So we can say print coordinates y is equal to 5 and x is equal to -1. Pretty straightforward. Don't need any kind of elaboration, I believe. But however, in case if you feel I can explain this to you. So you can see print underscore coordinates is y is equal to 5. We have given only the new value for parameter 5. But for the old one, it's still the same. That is -1. Let's go with the returning values. Okay. Okay, now this is what we have a good function, a good program which is coming up to understand this part. Returning values, now that we have seen how to pass parameters to a function, let's take a look at how we can return values from a function. Now, function values returning can be in the form of scalars, it can be in list or tuples. We will see how many different form of outputs we can see. So let's take a simple function that accepts a number as input and returns true if the number is even and false otherwise. So we are going to create a simple function that will accept some number as input and will return true if it is even. So same things what we saw in that list, correct? What was that? I for I, we saw that in list 1, if I is greater than this, then you print this. We saw that entire stuff for that, selecting only even and odd numbers in Python, correct? That's what we saw. So this is more or less the same. So define your function called as is even, and there is a single argument to that. And we are saying whatever single argument you divide it by 2, and if the remainder is logically equal to 0, you return true, else return false. Now you will see a new keyword which has come, which you have not seen before. Def, you know what it is. If you know what it is, else you know what it is. Return is something which you do not know. So return is, so in Python, it is not mandatory to use the return if the last logical execution line results in an object, the function returns the object. So, but however, in most of the functions which we still practice on a regular basis, we prefer to use return. So I have created a function. This is the entire block where the function is created. And now I will bring the function into little action. So print 2 is even. Use the function is even and let's specify the value. Here also the same thing. Use the function and specify the value. 2 is even question mark. It's true. 3 is even question mark. False. Correct? Very simple. Let's see this one. There was a question that can be put if then else conditional statement along with the def function, and that's what we are here. So definition of my function is that I want to check if it's even or not. If x divided by 2 is logically equal to 0, then it's true, else false. So this code is without a return keyword. And what happens when we try to run the same part? Can you see it actually giving none? As I said before, I mean, I haven't checked whether the return is mandatory in Python or not, but I always use return. I, as in me and my team or whoever we work as together, we prefer to use return because it does give you return values. You can see 2 is even none and 3 is even none. We can accommodate this with a return statement and it's going to give us the return values. How do you return multiple values? This is what I like, because previous one was returning only the scalars. What if you want to return list of values? So let's say define square and cube, that whatever input you're giving, you give me the square, you give me the cube of that. So return x into x, x into x into x. Parameters are passed assigned from left to right in function. That is correct. Shekhar, Girish, comma. I didn't get that part, Girish. Danish Khan saying return is not clear. See, return is means. Can you see the output here true and false because we actually checked whether this divisor is logically equal to 0 or not. And if it is logically equal to 0, that means it is an even number. So is even true and false. In this case, we did not use return. You can see this. And the output here is none. Can you see this? There's a indentation out here a bit. Can you see this? Initially, when I did not use the return, it was not giving me any values. It was giving me none. So I actually don't really see whether return is mandatory or not in functions in Python. I always use return because that's not going to harm anything in the system. So it's good to use return. I hope that's clear, Danish. Returning multiple values, define square and cube. This is also clear, I guess, because these are just operators. These are just operators. Either you make it 3 times or you do into 3. Okay, so let's see this. So x2 comma x3 square and cube of 3, 9 and 27 is something what I'm going to get as the answer. Now these things are a little tricky things. This will return 2 outputs. That's the reason we need 2 variables to store the value. Okay. The above function returns both the square and cube of any number passed to it. It returns both values in a single return statement. It is important we spend some more time understanding what's happening here. So let's see this. Is the function really returning 2 independent objects or it is returning a single object? The answer is the function is returning a single object, and then we are splitting that into the unpacking of that what we had studied. Remember the unpacking of the tuples. So the answer is function is returning a single object. Basically, the function is returning a tuple, and within the tuple we have 2 items. So the 2 items are getting unpacked when being assigned to the variables. So the syntax makes it appears like we have returned 2 independent variables. It's actually not like that. It's returning a single value like 9, 27, and we are just trying to bind and unpack that into a tuple. Okay. So however, what we have actually done is we have created a tuple called this one. And this returned is tuple and another, and then unpacked the tuple into 2 different values. Let's test this hypothesis. My value is equal to square and cube. So that means this function will return 2 values to you. So that means the function, the output for this should be 4 and 8, because we are wanting to return that as a tuple, right? And so when we say print of my value, it should be coming as 4 and 8 as a tuple here. And when you say, and this is going to be definitely a tuple. It's a class of tuple. So when we assign the return value to a single variable and printed the value, we can see that the value is indeed a tuple looking value and the tuple containing the corresponding result, that is square and the cube of the numbers. Correct. I hope this is clear. So in Python, we have control over the unpacking of the tuples. This allows us to custom unpack the tuple to cherry pick specific values. So let's see cherry picking, how we can do. Cherry picking is the things that we need the most from that unpacking of the tuple and other things we may not need. You can see that there are 2 values, x2 and underscore, okay, and square and cube. Print only x2, which is 9. 3 3s is 9. So 27 is also there, but that will come in underscore, I guess. You can see this. Okay, we can see that we are able to ignore the second value of the tuple and pick only x2. It worked perfectly without having to create a variable for x3. Whatever, but this underscore still had that value over there. What if you wanted to do the reverse? Nothing that gives the first as underscore, the second is x3, and then you print the x3 value, whatever we get that value as that. Now, some people might wonder that how we are loading two values in this by passing only this, because if you look at the body of square and cube function, the returns are two. There are two returns in this. You see this? Return square and cube. So there's a reason we are able to unpack that. Otherwise, we wouldn't be able to unpack it. Let's see this one. It is needless to mention that you can return anything from a function. The return could be a list, dictionary, sets, or any damn object that would matter to you for your thing. So the above could also be achieved by returning an array. So initially you saw that we were returning tuples, and we could have, it was written a bit differently. So how it was written? The only thing is we did not specify the tuple bracket. And remember, in yesterday's class, when we actually did the tuples, we can define a tuple this way. So I'm going to say insert cell above. I'm going to say that this is my tuple. How do you define a tuple? 2, 3, 4, right? But we saw in the notes, we can also define it this way. We don't need the brackets. That's what we did. Return this and this, and this and this and this. We can also make it this way, which I will prefer to do, because as I said, I use those brackets always. You can also do this. When we try to do this, this structure returned us results into a tuple. But this structure, which we're going to write, will return the list. This structure returned us the results into a never, I should write this, never changing tuple. This structure will return the list, which is changeable. So now you return the square and the cube and go this way. 3 square is 9, 3 cube is 27. You can see this. So there are a couple of more things. So we can also achieve the same thing by returning a dictionary as shown below. So guys, there was a question first. I'm not sure by Ishan, I guess, can we use dictionary as a parameter? We can use dictionary as a return object in this for the parameters we will see. So define square and cube, return x2 as your name, x and x as your values, x3 as your name, that is the key, and x and x cube into the. And how do you retrieve elements? Print 3 square is you return standing bracket x2, because x2 is the key, so you can return the values for the keys. Here also x3 is the key, and you can very well return the values for those keys. You can see how different, like we actually got the output in the return value in dictionary. Here also we got the return value in list. Before this, we got the return values in tuples. In any of the scenarios, we are able to unpack that and define that separately. This is not unpacking. Not unpacking. Unpacking is not here, but index-based retrievals. This is index-based retrievals or key-based returns. Okay, guys. So I would like to stop here for today from the learning perspective. I hope things are clear to you. I hope I have not created any confusion for you people. We know what are tuples, we know what are lists, we know what are dictionaries. Now we know what are functions also. And tomorrow we're going to create some basic functions, which are user-defined functions. We will also see what other functions are available in Python. And definitely we're going to proceed and try to finish this Python core on the files also. And this will get clear. This is not a topic more than 20 minutes or maybe half an hour max. But functions will take little half an hour. This files might take a little 20 minutes to little more than 20 minutes. So 1 hour, we'll try to, based on this, we can do Q&A, and then we will move on to our other topics for data science. So guys, any questions?
Thank you so much, Suvir. Thank you, everyone. Thank you, all of you, for joining us, again today. And we have a slide update for you. So we're going to actually change the schedule a little because we have been ahead of schedule. So what we're going to do is we're going to actually change the session for how machines learn. We're going to move that session to tomorrow, 11 a.m. And it's an absolute must-attend session if you want to begin your journey in data science. I'll be taking the session myself, and we will move that to 11 a.m. tomorrow on how machines learn. And what we will do is, because we have about 1 hour of Python left, we'll actually do the Python session on the next Saturday, next week, when we will finish off the Python functions, finish up file IO in Python, and we will then proceed immediately onto NumPy and Pandas. So it'll be an easier to continue than doing a 1 hour Python break tomorrow. So tomorrow we'll focus all about machine learning, understand how you throw data to machines and how machines learn from this data. So that's what tomorrow is going to be all about. The session is theoretical. It does not involve any coding. It's actually a conceptual session to give you an understanding of how really AI and ML really work. So if you're interested in learning those awesome topics, do join us again tomorrow at 11 a.m. And in addition to that, do not forget, we actually are going to run a 7 days of data science contest right after this. Tomorrow morning, we'll be announcing the contest, and the next weekend after that, we'll be announcing winners of the contest. So like all of you won the Echo Dots last week, we have a bunch of goodies to give out next week, and we're going to run a 7 weeks data science contest. This time it's going to be harder. It's not going to be as simple as posting something on LinkedIn and then getting a lucky draw. So more on this, stay tuned, more on this tomorrow at 11 a.m. So thank you so much, all of you, for joining in today. And I hope you enjoy a lovely Saturday evening. And please stay home and please stay safe. And we look forward to seeing you again tomorrow. Have a great day, everyone. Thank you so much.